All right, now we look at some day two problems. Problem number one here. Given the symbol, determine the element, the number of protons, neutrons, and electrons in the following species. Let's first talk about the notation that we have here. So X, it's labeled as X because I don't want to tell you which element it is. I want you to figure it out. We'll have what's down here at the bottom is labeled as Z, and what's up here at the top is labeled as A. Z is the atomic number. The atomic number is also available from the periodic table. So if we wanted to go ahead and cheat on this one, atomic number 5 is boron. And then A here is equal to the number of neutrons plus the number of protons. Okay, or we could also write that as neutrons plus Z, since Z is equal to the number of protons. And so in order to get neutrons in each case, it's going to be A minus Z. All right, so let's go ahead and hop into this first problem that we have here. A is equal to 11. Z is equal to 5. So the number of neutrons is equal to 11 minus 5. So this particular atom has 6 neutrons. 6 neutrons. This tells me the protons directly is 5. There's no charge indicated, and if there's no charge indicated, that means that the charge is 0. And so for the charge to be 0, if I have 5 positively charged particles, I must also have 5 negatively charged particles. And then finally, we already cheated, but let's say it again. So the atomic number is 5, so I can go down to my periodic table here and say that this is B. This is boron, the boron atom. All right, we'll do another one. Z in this case is equal to 20. I'm just reading that off. A is equal to 41. So the number of neutrons is equal to 41 minus 20. So 21 neutrons. Z is the same as the number of protons in every case. So 20. Number of neutrons we just calculated is 21. Again, there's no charge indicated. That means the charge is 0. So the protons and electrons must be the same. And then finally, we can go down to the periodic table. 20, atomic number of 20 would make this one be calcium. One more. Z in this case is equal to 53. A is equal to 127. So the number of neutrons is equal to 127 minus that 53. I need the calculator for this one. 127 minus 53. So there's 74 neutrons. 74. Number of protons they told us directly, 53. Again, there's no charge, so 53. And what element is this? I have to scroll down a little bit. 53 is iodine.